Hello people, welcome back. Today we are going to learn about how to plot the U chart. So the U chart we plot when your sample size is varying and you are still looking for the defect proportion out of a variable sample size. Let's say every day you have some inspection you are doing, audit you are doing, or sample testing you are doing. But the sample size vary every day. Sometimes you are doing 10, sometimes 12, sometimes 14, sometimes 8, sometimes 7. Or maybe this can be applicable when you are using the sample as a proportion of the total production. Suppose you have to do the 10% sampling and your production for the 2 days 100. So 10% of 100 is 10. If the production is 120, so 10% of that will be 12. So 10, 12, 13, 14, 8, 9, these are the variable sample size. And out of that, if you are looking for the defect, so let's say here you are observing the defect and here is the sample size. Maybe based on the production, some random sample you are picking up. So daily basis, maybe around 60 to 80 samples is what you do the audit. And out of that, how many defects you are observing? Let's say around minimum 10 to 25 defects you get in your production of these samples. And you have this data maybe collected for, let's say, last 20 days of the data is there. Now, out of these 20 days data, what is your defect proportion will come? So we can calculate the defect proportion by using 25 divided by 74. So defect proportion was around 35% or 0.35. Like this, we got the data. So when you are plotting over the control chart, this defect proportion will be plotted. So I just copy this data. Let's say paste in Minitab. So you have the defect which you have observed out of this sample size. You wanted to see the process remains in your statistical control or not. So for that, we plot the U chart. So we'll go to the stat. We'll go to the control charts, attribute chart, and here is the option of the U chart. You click on this. Your variable is defect and subgroup size you mentioned here, which is your sample data. Go to the U chart options, select the test, and select perform all the tests for the special cause. So test number 1 says if there is any one data point which is outside the k standard deviation from the center line, value of k is 3, which means in case any time the defect proportion is outside the 3 standard deviation from the center line, which is the average defect line, then the rule number 1 will fail. There is a special cause of variation which you must investigate and fix it. Rule number 2, k point in a row on the same side of the center line. If you have a 9 or more than 9 data point continuously, either they are below the average line or all the data points continuously, they are above the average line, or average line means average defect, then the rule number 2 will fail. Rule number 3, if you have 6 or more than 6 data point, they are all in increasing or decreasing order continuously, then the rule number 3 will fail. Rule number 4, if you have 14 data points in a row, they are alternating up and down. So one point is going up, one point is going down. If you have 14 data points continuously up and down, then the rule number 4 will fail. That means it's a special cause of variation. Now we'll click on OK and we'll see the result. You can see in this graph that there is a data here. So what do you observe? Rule number 4. Rule number 4 is failing here. What the rule number 4? 14 point in a row alternating up and down. You can see clearly this 1 point here, down, up, down, up, down, up, down, up, down, up, down, up, like this. And at the 14th point as it will come, the rule number 4 is failing. That means there is a specific pattern in this data set which you must need to investigate and fix it. That's how we interpret this. So control charts are very powerful to understand what symptom your process is going through, and we should never ignore the symptom of a process, otherwise this may turn out to be a defective product. Thank you so much, people, and I'll see you in the next session.